Okay, so today we are going to reduce radicals. Okay, so reducing radicals means that we're figuring out the factors or the roots of our radical. Okay, and then what that really means is what you're multiplying to get that number. Okay, so those are the factors or the roots. Now, 72 is not a perfect square, and it does reduce. So this is how you're going to do it. So we're going to make these things, we're going to call them factor trees. So 72. So you can pick a number that you know 72 goes into. So like 2 is going to go into 72 because it's even. So 2 times 36 is 72. And then 36 is made up of 6 times 6. And then 6 times 6, well, what makes up 6 is 2 and 3 and 2 and 3. Okay, so the roots or the factors of 72 are all of these little extra pieces on what I call like the leaves. So these are your branches and then your tree and then here are your leaves. So you need all of your leaf numbers. We can't let anybody, we can't leave them out. So we're going to put them in order from least to greatest. So I've got a 2, I have another 2 and another 2, and I have 2 3s. Now since there's no number on this shelf, there is technically a 2 on this shelf. So I'm looking for pairs, for twins. So I have a set of twins here, and I have a set of twins here, and then I've got this guy who's left over. All leftovers go under the radicals, and with the twins, one of them goes out and the other goes away. One of it goes out and the other goes away. Okay? So I'll show you what I mean. It's going out or in front of the radical. So we're going to bring the 2 out, and we're also going to bring the 3 out. Then we have our square root, and we have this 2 trapped inside because he didn't have a pair. Now I have these 2 numbers out in front. If you have 2 numbers or more out in front and 2 numbers or more on the inside, the operation that you use is always multiplication. So 2 times 3 is 6, and we have 6 root 2. So the square root of 72 reduces to 6 root 2. Now our calculators are super cool because they actually reduce our square roots for us, but they won't reduce our cube roots. So it's good to practice on the square roots and see that we know how to make factor trees so that when we do cube roots, we know we're doing those correctly. So let's try another one. So we're trying to find the square root of 75, and it is not a perfect square. So we are going to make our factor tree. So 75. Now I can't divide this guy by 5 or by 2 because he's not even. But 5 does go into 75, and 5 goes into 75 15 times. Now we want the very smallest factors that we can possibly get, so that's why we keep going. So 5 times 3 is 15. Now again, I'm going to put my numbers in order from least to greatest, and this time again, I'm looking for pairs, okay, twins. So I have 2 5s, and nothing that matches with the 3. So one of the 5s escapes, and the other goes away, and my 3 is stuck. So my answer is going to be 5 root 3. And again, we can check this on our calculator by doing the square root of 75, and that equals 5 root 3. So we did perfect. So now we're going to keep going. Okay, so the cube root of 625. So I will show you that cube roots don't work on this calculator. So it gives us a decimal. And that will not be acceptable for an answer. We have to reduce. So what we're going to do is we're going to make a factor tree for 625. Now 625 is a bigger number. So I'm going to see if there's a big number that fits into it so that my factor tree isn't really, really long. So it's got a 25. Maybe I can divide it by 25. Oh, hey, I can. Okay, so 625 divided by 25 is 25. And I know that 25 is made up of 5 times 5, and the same here. Okay, so that means that if I had 5 times 5 times 5 times 5, that would give me 625. That's what the factors mean. What you multiply to get your big number. This time, though, I want triplets. So I have 4 of them. So I'm going to look at 3 of them. And again, the same rules apply. 1 goes out, the other 2 go away. That's the same thing on 4th roots and 5th roots and all of those. When you're reducing, only one of the group of them that you're looking for, so like one of the pair of them or one of the 3 of them, gets out. And the others go away. And then this guy is stuck. So my answer will be 5, and it's the cube root of 5. Okay, so to check that on your calculator, we're going to do 5 times the cube root of 5, and we should get 8.54, which is what we got up here. So we did this correctly. We reduced it correctly. It just looks quite different than its decimal partner. Number 7. Number 7 is the same idea, so we're going to take our cute little 24 because he's not a perfect square. And I know 8 and 3 go into 24. And I know 8 is made up of 2 and 4. And 4 is made up of 2 and 2. So now I have all my leaves all done. I can't go any further. So now I'm going to write them from least to greatest. So I've got a 2, a 2, a 2, and a 3. And this time, since there's no number on the shelf, there's a 2, so I'm looking for pairs. So I've got a pair of 2s. 1 2 goes out, the other goes away, and 2 and 3 aren't pairs. So I'm going to take out my 2 and then my radical, and I've got my 2 and my 3 left over. And remember, if you have pieces left over, or more than one piece in each of these 2 spots, then they get multiplied. So my answer is going to be 2 root 6. And again, we can double check it. The square root of 24, oh no, the square root of 24 is 2 root 6. So we are. Okay, let's see here. Let's look on the back. For this guy, let's look at 13. So 13 is 45, again, not a perfect square. So 45 is 9 and 5. 9 reduces to 3 and 3. So I've got 3, 3, and 5. So I'm looking for a pair. So I've got 2 3s. 1 will go out and the other goes away. So I have 3 root 5 as an answer. Let's look at, 15. Let's do 15. So we've got 32. So 32, I can divide, 2 and 16 go into 32. And 16 is made up of 4 and 4. And 4s are each made up of 2 multiplying together. So I have 1, 2, 3, 4, 5 2s. I'm looking for 3 of them. 1 goes out, the others go away. So I pull my 2 out, my cube root of, I don't have any more triplets, so nothing else is coming out. And then I have 2 and 2 left over. Remember, we multiply. So 2 cube root 4. 17, these guys. You can do them a few different ways. You can reduce your radicals and then kind of combine them. Another thing that's really easy is this is basically the same thing as a really big square root, and it's 12 over 3. So 12 divided by 3 is 4, and the square root of 4 is 2. But remember, whenever we do square roots, we need the positive and the negative answer of them. Okay, and then the same thing with 19. So we have really a giant square root sign, and we're doing 400 over 4. So 400 divided by 4 is 100, and the square root of 100 is 10, so my answer is plus and minus 10. Okay, if you have any questions, please ask your teacher. I hope you have a great day. Bye, guys!